The PIC file register. The PIC microcontroller has many other registers in addition to the working register. They are called data memory space to distinguish them from program or code memory space. The data memory space in a PIC is a read-write or static RAM memory. In the PIC microcontroller literature, the data memory is also called the file register. In this section, then, we'll examine the various locations of file registers, data RAM in the PIC family, and discuss the usage with simple instructions such as add and move. The file register is read-write memory used by the CPU for data storage, scratchpad, and registers for internal use and functions. As with the working register, we can perform arithmetic and logic operations on many locations of the file register, the data RAM. The PIC microcontroller's file register size ranges from 32 bits to several thousand bits depending on the chip. Even within the same family, the size of the file register data RAM varies from chip to chip. Notice that the file register data RAM has a byte size width, just like the file register. The file working register. The file register data RAM in PIC is divided into two sections. The two sections then are the special function registers, the FSR, SFR, and the general purpose registers, GPR, and we introduced those some time ago. The general purpose register section is also referred to as the general purpose RAM or GPRAM section. So we'll take a look at each of these individually. First, let's look at the special function registers. The special function registers are dedicated to special functions such as ALU status, timers, serial communications, I/O ports, ADC, and so on. The function of each SFR is fixed by the CPU designer at the time of design because it's used to control the control of the microcontroller or any peripheral. The PIC SFR are 8-bit registers. The number of locations in the file register set aside for SFR depends on the pin numbers and the peripheral functions supported by that chip. That number can vary from chip to chip, even among members of the same family. Some have as few as 7, 8-pin for the PIC12C508 with no on-chip analog to digital converter, and some have over 100, the 40-pin PIC18 F458 with on-chip analog to digital converter. The more timers we have on a PIC chip, the more SFR registers we will have. We'll study that and the many uses of the SFR in future chapters. On the other hand, the general purpose registers, or the GPRAM, they're a group of RAM locations in the file registers that are used for data storage and scratchpad. Each location is 8 bits wide and can be used to store any data we want as long as it's 8-bit. Again, the number of RAM locations in the file register that are set aside for general purpose registers can vary from chip to chip, even among members of the same family. In the PIC controllers, the space that is not allocated to the SFRs typically are used for general purpose registers. That means that in a PIC chip with a 1,000-byte file register, no more than 100 bytes are used for SFRs and the rest are used for general purpose registers. A larger GPR size means more difficulties in managing these registers. If you use assembly language programming, in today's high-performance microcontroller, however, with over 1,000 bytes of GPR, the job of managing them is handled by C compilers. Indeed, C compilers are the very reason we need large GPR, since it makes it easier for C compilers to store programs and perform their jobs much easier.